Why don't I flinch? Because the laws of science differ fundamentally from all other. My face.
Hi guys, welcome to Science in 5. In this video we're going to discuss some important ideas concerning matter. Now, the question is always, what is matter? Whenever we start the discussion of chemistry, we always want to answer this question, what is matter? What is it made up of? Well, the simple answer that we can always give for what is matter is anything that is mass and volume. In this video, we're going to look at some of the important properties of matter, particularly the atom. Okay. What are the building blocks of matter? So if you look at a material, we can actually break it down to the smallest minute particles that actually make up this material. Those building blocks are called what? We call them atoms. Okay? An atom is the smallest basic structure of matter that can take part in a chemical reaction. The structure of the atom is very similar to the solar system of planets, where we have the sun in the center and the planets orbiting around. But in this case, we have the protons and neutrons forming the core of the atom and the electrons orbiting around. So in this model that we have got here, the positive represents the protons. Protons are positively charged particles found inside the nucleus. N is for neutrons. These are particles that have no charge. And orbiting around the protons and the neutrons are the electrons. So the protons and the neutrons form this core, which we refer to as the nucleus of the atom. Most of the matter of the atom is actually the nucleus. Most of the mass of an atom is actually, again, the nucleus. Because the protons and neutrons are found in the nucleus, we often refer to them as nucleons. Do all atoms have the same numbers of subatomic particles, protons, electrons, and neutrons? Well, the answer is no. That means all atoms would be identical. But we know that atoms are not the same. They're actually different atoms. Elements are pure substances that are made up of one type of atoms only. So if you have a material that is made up of identical atoms, we call that an element. Okay? Each atom of an element contains the same number of protons. So when we look at an element, we're saying these atoms of an element have got the same number of protons. And elements are placed on the periodic table in order of increasing proton numbers. Materials with identical atoms are called elements. And we find these elements on the periodic table. For example, hydrogen is assigned number 1 on the periodic table. This means there is 1 proton in hydrogen. So atoms of the element hydrogen will have 1 proton. Another example is aluminium. Aluminium is number 13 on the periodic table. Atoms of the element aluminium will have 13 protons in them. Another example is 78, number 78, the bling bling element, platinum. Platinum is given a number 78, which means there are 78 protons in an atom of platinum. Remember, the number of protons need to be the same. The neutron numbers and electron numbers can be different. But as long as 2 atoms have got the same number of protons, they belong to the same element. How are the electrons arranged outside the nucleus? Well, there's a pattern that they seem to follow. Okay? There's a pattern that electrons seem to follow. The first orbital always has 2 electrons. In other words, we can fit in a maximum of 2 electrons in the first orbital. Then the next orbital, we can fit in a maximum of 8 electrons. It could be 8 or it could be less. We can then write the electron numbers as 2 and then the number of electrons in the next orbital and so forth. In the atomic model that is given here, there is a total of 9 electrons. 2 electrons have gone into the first orbital, 7 electrons are in the next orbital. So the electron numbers are written as 2 7. We call that a Bohr notation. So Bohr notation gives us an idea of how the atomic model is actually, how the electrons actually arrange themselves outside the nucleus. Example number 1, we are asked to draw the atomic model diagram for carbon. We will need a periodic table for this activity. On the periodic table, carbon is number 6. So there are 6 protons in carbon. Since it's an element, it's in its element state, it's a neutral atom. 6 protons and 6 electrons. So we need to represent 6 electrons outside the nucleus of an atom. 2 electrons going to the first orbital, 4 electrons going to the next orbital. 2 electrons first orbital, 4 electrons second orbital. I have drawn the atomic model diagram for carbon. Okay. Second example, write down the Bohr notation for potassium, draw an atomic model for potassium atom. Again, I need the periodic table. Where is potassium? On the periodic table, potassium is number 19, which means there are 19 protons and 19 electrons. 2 electrons going to the first orbital. That leaves me a total of 17 electrons. I can't put 17 into the next orbital. I can place a maximum of, yes, 8. So I place 8 in. I've used now how many electrons? 8 plus 2, I've used 10. I'm now left with 9 electrons. Again, I can't place all the 9 into the next orbital. I can only place 8. That leaves me with 1 electron, which I can now place into the last orbital. So the Bohr notation for potassium is 2, 8, 8, 1. Once I have discovered what the Bohr notation is, I can easily draw the atomic model now. Here's my nucleus. I'm going to place 2 electrons into the first orbital. Then in the next orbital, I'm going to place 8 electrons. Right? In the next orbital, I'm going to place another 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And then in the last orbital, I must place how many electrons? 1. I have managed to draw the atomic model for a potassium atom. So guys, you see that the Bohr notation and the atomic model are more or less the same thing. The atomic model is actually the diagrammatic representation of the Bohr notation. Once you know how to write the Bohr notation, it should be easier for you now to draw the atomic model diagram. Now it's time for some practice questions. Don't disappear. Practice these questions by yourself. Compare your answers with what we've got here. At this point in time, you might pause the video, work out the question by yourself, and then check our answers. Okay. Question 1.1. Write down the Bohr notation for the following: sodium and chlorine. Draw atomic models for sodium and chlorine. Now, again, you need a periodic table for this kind of questions. Okay. On the periodic table, sodium is number 11. Sodium is number 11. So it means there are 11 protons and 11 electrons. So what would be the Bohr notation for this? Well, it will be 2 electrons in the first orbital, 8, and then 1. Check, if I count these numbers, they should give me 11. 2 plus 8 is 10 plus 1 gives me the 11. Chlorine on the periodic table is number 17. So there are 17 electrons that I need to work with. So 2 go into the first orbital, 8 into the next orbital, and 7 into the next orbital. Again, if I add these numbers, they should give me 17. 2 plus 8 plus 7 is giving me the 17 that I've got there. Now, once I've got the Bohr notations, it's much easier for me to draw the atomic model. Let's go for sodium. So there's my nucleus. 1, 2 electrons in the first orbital. Second orbital, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the next orbital, and in the last orbital, 1 electron. So my atomic model diagram for sodium is 2, 8, 1. For chlorine, just follow the Bohr notation again. First orbital, 1, 2 electrons. Next orbital, 8. 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Last orbital, 7 electrons. 1, 2, 3, 4, 5, 6, and 7. I've drawn the atomic model for chlorine. Okay. Question 2. Which of the following is the correct Bohr notation for magnesium? Okay. Well, on the periodic table, magnesium is number 12. So there should be 12 electrons that I need to arrange if I was to write the Bohr notation. Okay. So 12 electrons, 2, 8, and 2. Which of my options will be correct there? That is the correct answer, C. So C is the correct answer for this one, because I can see it is the correct Bohr notation for magnesium, which has 12 electrons. Which of the following elements has Bohr notation 2, 8, 8, and 2? Well, to solve this puzzle or this question, get the answer, I'm going to have to add the number of electrons. 2 plus 8 plus 8 plus 2. This gives me a total of 20 electrons. So I need to find out which element in its natural state has 20 electrons. On the periodic table, I'm going to look for element number 20, because we are saying the electron numbers are equal to the proton numbers. So the element has 20 protons. On the periodic table, which element has 20 protons is calcium. So the correct answer here would be calcium. Okay. And then question 4. The atomic model on the left is for which element? Now let's study this atomic model together. Well, the important information that we can see is their electron numbers in the orbitals. So I've got 2 electrons in the first orbital. Then I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons in the next orbital. And I got 1, 2, 3, 4, 5, 6 in the last orbital. So the total number of electrons here is 16. So which means there must be a total number of 16 protons. Now, which element has got 16 protons on the periodic table? Guys, check on the periodic table. You discover that the element is sulfur. So the correct answer there would be A. At this point in time, that is our discussion on how the atom is arranged, the smallest building blocks of matter. How do the electrons fill up the orbitals? We use the Bohr notation. The first orbital takes 2 electrons. The next orbital can take in a maximum of 8 electrons. For now, we are focusing on the first 20 elements. Okay? If we go beyond the first 20 elements, we could get some kind of entanglement with our chemistry. But we're introducing chemistry at this point in time. We don't want any entanglement, of course, unless you want entanglement. But we can make our chemistry a little bit more complicated for now. So let's focus on the first 20 elements where we follow that pattern. 2, first orbital, maximum of 8 and 8 in the following orbitals. Okay, thanks guys for watching. Please subscribe to Science in 5. We've got more and more easy explanations that can make your science and maths journey easy and pleasurable. Thanks for watching guys. See you guys next time.